Okay, here we have a real table now, and as before, as in the previous video, we have IDs here as well. You see, beach ID, volunteer ID, and district ID. So we will start with moving these IDs away from the original table with their dependents, with their children, yeah? As if all the ID fields are parents and all the dependent fields, all their dependent fields are children. We will start by moving an entity that is live, that is alive, like a person, yeah? Not an object. These are all entities, you see? Beach, every noun in the dictionary is an entity. You can see here that beach is an entity, rubbish is an entity, district is an entity, yeah, cleanups is an entity. All of these are entities. We start with an entity that is live, that is not an object. It's, let's say, a human being. We have two here. We have the volunteer and the lifeguard, but the lifeguard doesn't have any ID. So we will start with volunteer. These are not live creatures, yeah? These are, let's say, things, objects, yeah? The district, the beach, the rubbish, etc. So let's examine its dependence, starting from the right here. What does dependent mean? It means that for the same ID, the data of a dependent is always the same, yeah? So if we see here, let's start with, because beach ID is its own entity, yeah? Now we will start with another field that may be a dependent on the volunteer. We see here that volunteer ID 1 here, in one case it's got 125 kilos and the other one is 149. Straight away we know that the volunteer is not dependent on that. The rubbish collected is not dependent on the volunteer ID. Number cleanups of the beach, for volunteer ID 1 it doesn't show any different, but if we go down to volunteer ID 1 down here, we will see that it's a 1 in one case and a 0 in another case. It has to be the same. Dependent means that it is the same value always for the same ID, but here it changes. So that's not dependent. The district name, we have to be careful. Look at that, there is a district ID, so it probably depends on that. So we have to leave it. Now the years, see, in one case it's 18 and one 19. So that is how we examine whether any other field depends on the ID in question. Yeah. Now there are fields that are labeled with the entity's name. For instance, here we have volunteer mobile, that we can see that volunteer ID 1 is always that mobile number here. Yeah, always that number. See, that ends in 29. Here as well, the same volunteer 1 has, yeah, and the volunteer surname is always volunteer, corresponds to the, it depends on the volunteer ID. So now we know that these three fields, volunteer ID and these two fields here, go all together. Let's move on to finding another entity, yeah, another ID. We can do district or beach. Let's do beach, that is on the left, yeah. However, we forgot something, that each time we move a family of a group of fields to another table, we always leave a copy of the ID, yeah, as we showed in the previous video. So there you have it. I added it, and now I'm linking all these tables together, so that now so far we have two tables. Let's find the dependence of beach ID. So rubbish collected is not dependent. You can see here that it is not dependent, yeah, because for the same ID we have two different values of rubbish collected weight. Number of cleanups seems to at first glance seems to be dependent, but if we go down to beach ID 3, in one case it's 1 and another case it's 0, so it doesn't depend. District name could depend, however you have a district ID, so you have to leave that to depend on its district ID. Review year, we have two different values for the same ID. Now beach name, obviously it has inherited its entities label, so it's called beach name. That depends on the beach ID. You can prove that yourselves if you move this table up and down. Yeah, see that it corresponds. Yeah, here, here, and here, as well as beach type. There's only one beach type per beach. Yeah, so here we have sand and shingle, sand and rock, and for beach ID 1 we have sandy beach. The lifeguard seems to depend on it. I will talk about it later. It will be left on its own at the end. We'll decide. District and cleanliness review seems not to depend. Yeah, and district is its own entity, its own table. So now we know that we can move beach ID to a separate table here with its beach name and its beach type. And as always, we moved an entity to its own group, and we have to leave behind the ID. Okay, so let's stick the ID somewhere here. It doesn't matter where. Let's move these back together. And now we have 3 tables. And these 2 tables are linking with this table because their IDs are repeated in this table, yeah? Now let's take the district ID. Here we have the district ID. Let's examine its dependencies first of all. So you have, if you examine for starters, the rubbish collected, the weight. For district ID 1, you have 2 different values. See, for district ID 1, you have 2 different values. For number of cleanups per year, you have 2 different values here. For ID 3, you have 2 different values there. The district name is obviously matching the ID, and it has inherited, it's a dependent of the district ID, the district name, yeah? So these 2 go together. Beach ID is the key that we left behind from beach. Volunteer ID, the key that we left behind from volunteer. Now, lifeguard, it looks as if it's dependent, but it was dependent as well on the beach. So we have to make a decision about the lifeguard using our common sense. We'll do that at the end. Yeah. Does the district have a lifeguard, or does the beach have a lifeguard? Cleanliness review, we see here that for district ID 2 we have 2 different values, so that the cleanliness rating review is not a dependent of district ID. Now that we found the dependence, let's move the district ID to a separate table, and district name, and as always leave a copy of district ID behind. So far we have 4 tables. We have the volunteer table, the beach table, the district table, and all 3 tables have left an ID back onto the original table, so they link to the original table. However, let's bring in a twist. The twist is that a volunteer may be assigned to 1 or more districts. So basically the volunteer ID that we left linking, we cannot take it from its original table, yeah? We cannot move IDs from their original table. But we left the volunteer ID in the cleaning table here, the beach cleaning table. So basically we have to move this ID to the district, because it actually, the volunteer is assigned to 1 or more districts, the scenario says, yeah? E.g. borough side, yeah? So for instance we have volunteer 1 here, is always dependent. You see, there is a slight dependency here. Volunteer 2, yeah, it matches this part of the scenario. There is no doubt that this is feasible, yeah. So we brought in that little twist, and be careful with these little twists because they're hidden and we might mess up our normalization. Now there's a gap there that we have to fill in, and now that we clarified that, lifeguard does not depend on the act of cleaning here. It depends on either the beach or the volunteer. It matches both. If we move the lifeguard down here, and this is not an ID, yeah, so we don't have to leave any keys behind. So if we move this here, it matches both, yeah, so it looks like it depends both. But let's use our common sense. Would you employ a volunteer to clean a beach and then label him as well as a lifeguard, or would you assign a lifeguard to the beach? You would say whether the beach has a lifeguard, yes or no. To me it seems reasonable that this is where it goes, yeah. Now that is as well, let's move this a bit further so that we have the tables clear. You have to use your common sense for certain things. We know that beach ID, let's move these closer. We know that beach ID and district ID are remnants from moving the beach and the district table, as well as the volunteer ID here is because the scenario told us so. These seem to be the remnants of the original group that define precisely, if you look, the elements, the details of cleaning the beach. So this is beach cleaning, yeah, it's the beach cleaning table. So we can call this, if we just get another text field, we can call this beach cleaning, or give it any other name according to the scenario. If we read a scenario, where is that scenario? We'll talk about that later, yeah. So that is now the end of our normalization. As we previously did with our family, with the family members, we have moved all the IDs on separate tables with their dependents. We learned what dependents are, and basically we have now 4 tables and not just one.